Hello everybody and welcome to our video on trig review, talking about trig graphs. So we're continuing along with chapter 10. Okay, and I just want to review the shapes of the basic graphs. So the basic sine function has a shape that looks like this. It has a mountain and a valley, if you like to think of it that way. It has a period of 2 pi. It takes 2 pi to do a full cycle. And it has a maximum at 1 and a minimum at -1. Okay. The amplitude, therefore, is only 1, and the axis is y equals 0. There are 5 key points. We've got 0, 0, pi over 2 and 1, pi and 0, 3 pi over 2, and -1, and 2 pi and 0. Its domain is x belongs to real because it continues. It's a continuous function, but it has a range between -1 and 1 because the highest it ever gets is 1, and the lowest it ever gets is -1. That's why when you try to type into your calculator and find a trig value for, take sine inverse of a number bigger than 1, your calculator says error. The basic cosine function looks fairly similar. It's the sine function just shifted a little bit. It has a 5 key points, 0 and 1, pi over 2 and 0, pi and -1, 3 pi over 2 and 0, and 2 pi and 1. It has a period of 2 pi. It takes 2 pi to do this full rotation. The axis is y equals 0. It has a domain of x belongs to real numbers because it is continuous, and a range similar to the sine function with a maximum of 1 and a minimum of -1. Okay? Notice that they are horizontal translations of each other. If I shift the sine function pi over 2 units to the left, I'll get the cosine function. Or if I shift it 3 pi over 2 units to the right. Okay. We also have the basic tan function. And the tan function looks much different. The tan function has it has asymptotes starting at pi over 2 and repeating every pi units. Okay, and it has these vertical asymptotes wherever cos of theta equals 0, because tan theta is equal to sine theta over cosine theta. So anytime that cosine theta equals 0, imagine our cosine theta graph tracing through here. Anytime cosine has a 0, we have an asymptote for the tan function. It also has no absolute max or min because it stretches to positive infinity and negative infinity, so it never reaches a max or a min. The period is pi. We don't define the amplitude. It still has an axis. It kind of does a swoopy thing. It sort of has like a half shape here and another half up like that. And the domain is tricky because we have to include all of these asymptotes. So we usually state this as pi over 2 plus k pi. X cannot equal pi over 2, 3 pi over 2, or any pi over 2s plus a multiple of pi. And the range is y belongs to real because there's no max or min.